sklearn, neighbors, kernel density. Description: a non-parametric method for density estimation. It works by placing a kernel function e.g. Gaussian at each data point and summing the kernels to estimate the probability density. Inputs: x, the training data used to fit the model. Shape, n samples. N features. Bandwidth, the width of the kernel function. This is a key parameter that controls the smoothness of the density estimate. Outputs: sksamples returns the log density for each sample in X. Sample generates random samples from the estimated density. Steps: fit the model to the training data X. Determine the probability density at any point based on the kernel function and the distances to the training points. Metrics: log likelihood score measures the fit of the model to the training data. Cross-validation score evaluates the performance of the model on unseen data. Visualization plots: density plot visualizes the estimated probability density function. Contour plot plots the contours of the estimated density function. Fine-tune parameters: bandwidth controls the smoothness of the density estimate. Larger bandwidth leads to smoother estimates. Kernel: the kernel function used to estimate the density. Common options are Gaussian, Epernechnikov, and top hat. Uncertainty methods: bootstrap estimate uncertainty by resampling the data and fitting multiple models. Cross-validation estimate uncertainty by evaluating the model on different subsets of the data. Challenges and fixes. Challenge 1: choosing the optimal bandwidth. A bandwidth that is too small can lead to overfitting, while a bandwidth that is too large can lead to underfitting. Sample use case that resulted in challenge 1: fitting a kernel density estimator with a bandwidth that is too small to a dataset with many outliers. This results in a highly irregular density estimate that does not accurately reflect the underlying distribution. Fixes to challenge 1: use cross-validation to find the optimal bandwidth. Consider using adaptive bandwidth techniques that vary the bandwidth based on the density of A data. Challenge 2: handling high-dimensional data. As the dimensionality of the data increases, it becomes more difficult to estimate the density accurately. Sample use case that resulted in challenge 2: fitting a kernel density estimator with a large number of features. This can result in a density estimate that is overly smooth and does not capture the true distribution of the data. Fixes to challenge 2: consider using dimension reduction techniques to reduce the dimensionality of the data before fitting the model. Experiment with different kernel functions to find one that is better suited to high-dimensional data.